الفوق الصوتية. Absorption of ultrasound beam is the removing of energy from the beam due to the frictional force that opposes the motion of the particle in the medium. This removed energy is converted to heat. Thus absorption refers to the conversion of ultrasonic energy to thermal energy. There are three factors determining the amount of absorption of ultrasound beam in the medium, which are the viscosity of conducting medium, relaxation time of molecules, and the frequency of ultrasound. The viscosity of conducting medium. The importance of viscosity is above in ultrasound beam absorption because ultrasound is being composed from vibrating particles. With increasing viscosity, the particle freedom decreases and the internal friction increases. This will lead to absorption of energy from the beam by converting ultrasound energy to heat. And the intensity of the ultrasound beam decreases. Relaxation time. The relaxation time is the time that it takes from a molecule to return to its original position after it has been displaced. The relaxation time is constant for any particular medium. Two media with the same viscosity may have different relaxation time. When a molecule with a short relaxation time is pushed by ultrasound waves, it has a time to return to its resting state before the next compression wave arrives. This means that the molecules moves in the opposite direction of the wave, and more energy from the ultrasound wave is required to reverse the direction of molecule, which is converted to heat. The frequency of ultrasound. We can explain in soft tissue there is a linear relation between absorption of ultrasound and frequency. Absorption is nearly doubled when frequency is doubled, and it is halved when the frequency is halved. The high frequency beams have an advantage over low frequency beams. That is, the deep resolution is superior with high frequency. High frequency beams have this advantage that the absorption of ultrasound wave increase with the frequency increase, because high frequency ultrasound have shorter waves that are easily absorbed or attenuated by the tissue. A relatively low frequency beam is required to penetrate thick parts of the body. Lower frequencies produce less resolution, but it can image the deeper parts in the body. Thus, they are capable to be reflected or scattered from similar structures. For this, we require lower frequencies for abdominal diagnosis and high frequencies for superficial diagnosis. في هذا الجدول نعرض أنواع الترددات موجات فوق صوتية، وقيمتها، وكل قيمة من القيم ممكن نسوي لها اكزام او نحصل ايمج جزء او اجزاء من الجسم، بما معناته بان كل قيمة من الفريكونسي لها فد جزء معين من الجسم ممكن ان نسوي اكزام عليه ونحصل ايمج. مثلا عندنا 2.5 ميجا هرتز نستخدمها بالابدومينال obstetric and gynecological. 3.5 megahertz use general abdominal obstetric and gynecological. 5 megahertz use vascular, breast and pelvic. 7.5 megahertz use for breast and throat. 10 استخدم breast, throat, specific veins, specific muscles and muscle skeleton. 15 specific structures and muscle skeleton. هذا guideline for each frequency and what is the part we can to get a good image from it. In general, ultrasonography can be used in examination of heart and blood vessels, identify size and structure change in pelvic organs, identifying and distinguishing cancers and benign cysts, evaluation of tumors and foreign bodies of the eyes, demonstration of retinal detachment and the field of obstetrical and gynecology. Ionizing radiation is to be avoided whenever possible in some diagnoses, such as evaluation of fetal size, maturity, fetal and placental position, multiple pregnancy, uterine tumors, and other pelvic masses, including abscesses. Decibels may have either a positive or negative sign depends on gain or lose in ultrasound energy. Ultrasound loses energy as it passes through tissues, and the intensity of returning echo relative to the original beam is negative number of decibel. ذكرنا في المحاضرة مصطلح الأكوستيك إمبيدنس وأهميته. هسه راح نوضح الأكوستيك إمبيدنس بشكل أدق وتفصيل أكثر. Acoustic impedance is a fundamental property of matter. It is the resistance that an ultrasound beam encounters as it passes through the tissue. It is an expression of the opposition to passage of sound wave, and it depends on the density of tissue and speed of sound wave in the tissue. The density of tissue is measured in gram divided centimeter cubic, and the velocity of sound wave is measured in centimeter divided second. Therefore, the acoustic impedance is measured in real. The acoustic impedance is Z is given by Z equal intensity multiply velocity of ultrasound wave. في هذا السلايد راح نوضح فد مثال بسيط، وهو حساب الممانعة الصوتية الاكوستيك امبيدنس للماء، حيث يكون سرعة الصوت بالماء 1540 متر على ثانية، ونعرف كل زين بأن كثافة الماء هو 1 غرام على سنتيمتر مكعب. الحل هو تحويل السرعة من المتر على ثانية إلى سنتيمتر، نضرب في 100 فيتحول لنا السرعة إلى سنتيمتر على ثانية، ونطبق القانون مال الممانعة الصوتية، هي الكثافة في سرعة الصوت، وعن طريقها ممكن نحسب الممانعة الصوتية للماء. وهذه الطريقة عند معرفة كثافة أي مادة ممكن حساب الممانعة الصوتية. مثلا التشو من نعرف سرعة الموجات الفوق الصوتية، ممكن حساب الممانعة الصوتية. كذلك إذا عندنا مثلا موجودة الممانعة الصوتية ممكن أن نحسب كثافة المادة، مثل الأنسجة نعرف مثلا سرعة الموجات الفوق الصوتية، والممانعة الصوتية لهذه المواد عن طريقها ممكن نحسب الكثافة لأي مادة احنا نريد نحسبها. إلى هنا ينتهي هذا الفصل. تمنياتي لكم بالموفقية والنجاح، وشكرا.